Pointer is very important and powerful concept in programming, but it is very difficult to understand. In this lesson, I will explain this concept to you. To understand pointers, we should understand how the variables are stored in computer memory. So let us assume this is the computer memory. When we talk about computer memory, it always means the main memory or the RAM. So this memory is divided into a number of blocks where each block are of 1 byte. So let us assume that this block is 1 byte. Like every house in a row has an unique address, in the similar fashion, each block in this memory has a specific address. So let's assume the address of the first block of this memory is 0 and the address of the last block is the maximum capacity of the memory. Say for example, the address of this block, say it is 100, the next block will be 101, the next will be 102, 103, 104, 105 and so on. In the similar fashion, say this is 200, 201, 202. So now when we declare a variable in our program, it occupies some space in this memory, or we can say that the compiler allocates some blocks to this variable. So let's we say we declare a variable in our program, say int a. So when we write int a, compiler will define a variable a with the data type of integer and it allocates some amount of memory. Amount of memory depends upon the data type and the architecture of the computer also. So like integer in a 16-bit computer architecture, the computer will allocate 2 bytes of memory, whereas in 32-bit computer, it allocates 4 bytes of memory for one integer data type. Similarly, for character data type like char C, 1 byte of the memory will be allocated. So as soon as a variable is declared, during the program execution, the compiler allocates the required amount of memory. In our example, say a variable a is declared as integer data type, so the computer will allocate 4 bytes of memory. Let's say it allocates the 4 byte of memory starting at location 100. So the variable a will be stored at the location 100 to 103. So this 4 bytes will be allocated to the variable a. Compiler also stores this information into a lookup table. So a lookup table will contain the name of the variable, the data type of the variable and the address. So when we declare the variable a, it will be stored in a lookup table like a and type is integer and the starting address is 100. Similarly, when we declare another variable c that is of character type, it will say for example the c allocates the memory address 104, it is allocated by c. So in the lookup table it will be stored as c, the type is character and the starting address is 104. When we perform some operations to these variables, like for example if we initiate the value of a by say a equals to 5, the computer will go to the address 100 and stores 5 in the next 4 bytes. The value 5 is stored here. Similarly, when we change the value of any variable, say we increment a, so now the value of a will be changed from 5 to 6 and it will be stored in the same location. Now the question is, can we know the address of a variable? Or can we perform operations on the value which is stored at some address in the memory? The answer is yes. We can do this using the concept of pointer in C programming. So what exactly pointer is? Pointers are variables that store the address of another variable. A pointer uses two operators. One is the referencing operator, that is ampersand symbol. It is also known as address of. The second operator, which is known as dereferencing operator, that is the asterisk, and it is also called value at. Now consider the declaration int a equals to 5. What does this declaration means? The system or the computer reserves space in the memory, name the space as a, and it stores the value 5 in this space. Now, how can we get the location of this variable? We can get the location by using the ampersand operator. So, if we write printf ampersand a, what should it print? It should print 100, because in this case the address of a is 100. This ampersand tells the compiler that it is the address of the variable a. And obviously we can get the value by simple printing the variable name. When we execute this, it will print 5 because the value of a is 5. So whenever we need address of a particular variable, we use the ampersand operator. Definition of the pointer says it stores address of a variable. It means if we use a pointer variable p to store the address of a, we must assign the address of a to the pointer p. Say p equals ampersand a. What does it mean? It means the address of a will be stored in p. But wait, we need to declare p. So now p is not an ordinary variable. It must be declared as a pointer because it is storing the address of a variable. So pointer is always declared with the asterisk symbol. So we declare p as int asterisk p. So it means p is a pointer variable which stores address of some other variable. So by writing int before pointer p, we are telling the compiler that p is a pointer to an integer variable. Now we have a variable a which stores the value, and we have another variable p which is a pointer to an integer. Now we assigned p with address of a. So it means the p will be storing the address of a. Let's, for example, the p is stored in memory location 200. So when we write p equals to ampersand a, the address of a will be stored at location 200. It means p is a pointer which is pointing to a. Now, how to use the pointer variable? We can use the value by dereferencing operator, that is the asterisk, or value at. Suppose we want to know the value of the variable which p is pointing to. So we can get it by writing the printf statement with asterisk p. So this will print the value. And if we write printf p, because p is storing the address of a, it will print 100. So it means because p is basically the address of a is nothing, simply it is the value at the address of a. So if you print this, it will also print the value 5. Now, important point to note that if we have two pointers, one is int asterisk p, another one is float asterisk f. Float asterisk f, it does not mean f is float. It means f is pointing to a variable which is float type. By default, f is an integer because it stores the address of a variable. So please do not confuse with this that float asterisk f means f is float. No, f is not float. Variable which f will be pointing to is of float type. Can we change the reference of a pointer? Yes, we can change. Let's say we have a variable a type integer and the value is 5, and we have defined a pointer p. Suppose p is having the reference of a. Now if we print the value of p, it should print 5. Now we can change the value of this variable a by two ways. First, we can write a equals to 8, the new value of a. Second, we can change the value of a by writing asterisk p equals to 8 because the value a and asterisk p are the same thing. As I already told you that asterisk p means nothing but it is asterisk address a. So now suppose we have another variable b initialized with a value 12. What will be the output of these two statements? The first asterisk p equals to b and the second p equals to ampersand b. This statement will do nothing but simply changes the value which is pointed by p to the value of b. It means suppose in our memory we have three locations. One is p, one is a, and the third one is b. So suppose the value of a is 5, value of b is 12. Now when p is ampersand a, it means p is pointing to a. So the value at the address p is 5. Now if we use asterisk p equals to b, it means the value at the address p will be updated with the value of b. It means we are updating this value with 12. Now what is the second? P equals to ampersand b. Now when we write p equals to ampersand b, it means p is now ampersand b. Means now the p is pointing to b. So in the first case, when we write asterisk p equals to b, we are doing nothing but changing the value of a. And in this case, by writing p equals to ampersand b, we are changing the reference of p. Now p is referring to the variable b. I think now the basic concept of pointer is clear.